Good evening. This is Homa. I'm working on a NorCal 140 radio kit. It's almost done. I'm at the stage where the oscillator circuit has been put together and is working, and this is basically demonstrating that it works. Okay. Over here is the frequency counter. Since I used an oscilloscope probe, I don't want to select the 50 ohm option on the frequency counter, so I just left it at 1 mega ohm as it is right now. The trigger sensitivity thing should be on, and it doesn't really make a difference to the frequency if I put the DC or AC option in this case. Sometimes it does make a difference. And those are the main settings I messed with for the frequency counter. And the frequency I'm measuring is the oscillator, obviously. And as you can see, this scope probe is running from the counter, and its input is the oscillator loop over there where my finger is, and then there's a ground loop that I also soldered in that's a little bit beside it where the black lead is hooked to right now. And one important part of this oscillator is the inductor over here. This inductor has 59 turns right now, and it made a huge difference when I took off 2 turns, because I originally wound this thing with 61 turns, and it made a difference of about 4 microhenries when I took off 2 turns. It went from 21 microhenries to about 17 microhenries when I measured it with an RLC meter, with the 2 leads of the wound toroid being clipped to the leads of the RLC meter. And it was important when I was measuring the inductance of this wound toroid. It was for the enamel to be stripped off of the wire ends. As you can see here, there's a shiny part. Let me see if I can put this into better focus. Alright. Okay, I'll just try to point to it. Right there, you can see it's shiny. It's because I sanded off the red enamel, and that was for both ends, both the one on the left and the one on the right that I'm pointing to. Otherwise, when you put the 2 ends and put them into the leads of this RLC multimeter thing over here, you will get basically it'll claim that it's overloaded, and the inductance will seem a lot more than it actually is, or it'll just refuse to take a measurement. And so, yeah. Anyway, 17 microhenries. You wouldn't think 4 microhenries can make such a huge difference, but it can, because the frequency counter measurements that I had when I had 61 turns were about, it was about a 1 kilohertz difference, I'd estimate, when I took off the turns. So I had about 2.072 megahertz when, even after tuning everything, for the frequency of my oscillator when I had 61 turns. And instead I was able to tune to 2.085 megahertz. So actually that would be more like, well, anyway, it's a huge difference in frequency. And it just goes to show how much electromagnetics has an impact on, especially on circuits with components of this size, when they're that small. Okay, here are the potentiometer knobs of this radio as it's in progress. I'll note here that this oscillator that I've been talking about is in the receiver part. Because with if there were a shorting plug over here where I'm pointing, and you shorted them, and you shorted these two ends together by having wire like this. If you used wire like this to hook these two leads, these two ends together, then you're basically simulating the transmitter switch, and in that case, the transmitter switch in this case, you're simulating the transmitter switch being 8 volts and on. And when that happens, this potentiometer over here doesn't change the frequency that much, as I found out through the frequency counter measurements. Whereas this potentiometer always has an impact regardless of whether the transmitter is on or off. Right now the shorting leads are not there, so the transmitter is not on. Like I said earlier, when it's on, it's 8 volts. And this is a unique kind of capacitor. What I'm just pointing to right here, this white, gold, gray thing. When it's in the bottom position, the capacitance is at its max. Well, sorry, the frequency is at its max. When it's in its top position and the round part is away from me as opposed to toward me right now, then the frequency is at a minimum. And it's exactly halfway in between when you go to the left or to the right. Doesn't really matter. In both cases, the frequency will be about halfway. So that's a new thing a new kind of capacitor that I hadn't seen before I started this transceiver radio project. This project is for a wireless electronics class that I'm taking in my undergrad. I'm an undergraduate student in electrical engineering, and I felt like taking this video just to show off some stuff. I hope some of this was either enjoyable or informative, and apologies for the camera issues and potential stuttering issues in this video. I don't make these very often, but I just thought this was a video worth sharing. Oh, and there's the power supply that I used to power up, to set both the 1.4 volt 1.4 volts offset as an input into this oscillator circuit that has a comparator in it. The offset was needed so that the comparator would be able to do its job, and so I used the 6 volts limit to set that particular 1.4 volt offset. I used the 25 plus minus 25 volt option and set the power supply of this entire board basically to 12 volts, and that's what you see here. There's some leads that were soldered on to this this power supply jack, and I'm pleasantly surprised that everything is still working as well as it is at this stage, especially with all the transistors and wound inductors that are involved and potentiometers. Anyway, have a great day, and I will post more updates about this radio transceiver as I progress further. Later.